There are two types of bypass valve on the MC18 pump. There's the old one, which looks like this, which has got essentially three parts: the sealed plastic assembly with a stainless steel washer and a turret similar to that you'll find inside the plug casing. Now these have a rubber seal sat inside the casing which guides the stainless steel bypass pin, which is essentially the unloader stem. Now these tend, if they're not washed through properly, to get full of salt and corrosion from the salt, and if you clean these out every once in a while they'll last an awful lot longer. But to put it back together, you essentially pop it in like that, flip it up, and then screw it down into the casing. If you've got the new type, it'll look like this, with a big top on it with a plus and minus. These are in two parts, which is the turret and the plastic control knob with the stem built in. The difference is these have, instead of the little rubber seal, these have a small O-ring in the stem, which Comet have done for one reason or another. I suspect it creates a better seal on the inside of the casing. If you look inside the pump, there's a big stainless steel washer almost, which is the seat for the unloader valve. If you just use a pen, you can usually pull it out, and it's got a chamfered edge on the top side and it's flat at the bottom, and that sits on top of an O-ring. So again, that goes down onto there. That assembly then just screws in the same way that you don't need to do the plug casings up too tight. This is only sealing on this bottom O-ring, so you only need to do it just until the O-ring started to disappear into the head casing, which we can't do it up anymore. If in doubt, run the machine up with some fresh water in it, and if it's leaking, do it up a bit tighter. If it isn't, you've done it enough. The valves obviously screw all the way up and all the way down, but usually if I want maximum pressure from the machine, I'd screw it all the way down and then take it back half a turn. This then relieves some of the pressure on the seat and on the stem. If you do this, it has a tendency to prevent it from sticking if it is got salt build-up and things like that. Obviously if it's screwed hard down in the same way as with a pressure washer, you're more likely to get difficulty bypassing. Obviously the more pressure there is on the spring, the higher the build-up of pressure you need for it to release and divert the water. There's not much else with these. There's not many moving parts. The only other component that really rotates is inside this casing in an oil bath, which the only reason you'd ever have to change the oil would be if the diaphragm were to fail and the oil bath were to fill up with water. Obviously then the top cover would come off and there'd be water and oil inside this casing, which you shouldn't get. Again, the diaphragms are virtually impervious to sodium hypochlorite. It's only the metal components of the pump that are really susceptible. Obviously for the caps to go, the bypass valve has to fail to work. If the bypass valve fails to put the pump into bypass, it'll look for the nearest weakest point. Obviously the valves are sacrificial, they're plastic, so when the pressure buildup is too great, one of the caps will split and the water will come out. If the caps didn't split, it'd just find the next nearest place to obviously offset the pressure, so it'd split the hose or something like that, in a similar way to the way the pressure washer will do. If the hydraulic hoses fail when the unloader goes, you'll either lose one of your valve caps on your pump head or bolt, or the unloader valve will start to seep from the stem seal. And that should just about cover it.